Okay, this is lesson 2 and it is about properties of soil. What are properties of soil? Soil properties refer to the chemical and physical characteristics of the soil. The chemical and physical characteristics of soil are what we call properties of soil. And these properties of soil include, number 1, soil structure. This is about the arrangement and the shape of individual soil particles. Soil particles have different arrangements and shapes. And under soil structure, we have, one can call them examples of soil structure or types of soil structure. We have granular and clump structure. Granular and clump structure have their soil particles spherical in shape. Then we have plate. The particles in plate structure are in form of thin plates or sheets, and they are horizontally arranged on one another. Then we have prismatic soil structure. The soil particles are in form of vertical prism with parallel ends. Then we have columnar structure. This one is almost similar to prismatic, only that the particles in columnar structure are rounded at the top. They have round tops. Then we have block structure. Here the soil particles cling together in irregular shape or angular blocks. They are angular blocks having more or less sharp edges. More or less sharp edges. I think this diagram tries to show how they look like in shape and maybe arrangement. This one indicates prismatic. This one indicates blocky. This one indicates granular, and this is plate. Then we have another property of soil texture. It refers to the size. Here we concentrate on size of the soil particles. Some soil particles are smaller than others. Others are big, small, and medium. That's why we are able to classify soils or particles like clay, sand, and the biggest particles, we always call them stones. Soil texture is very important because it influences the amount of air and water available within the soil. It also influences the amount of water and the ability of the roots to pass through the soil. It determines the ease with which plant roots can penetrate the soil, and it also determines the soil's ability to retain humus, the other decayed matter. It influences aeration in soil. Another property, color. Soil has color. Some soils are red, others are yellow, others are black, others are gray, others are brown. And this is identified just by seeing, using your eyes. We have soil porosity. This refers to the number of pore spaces in the soil. Does soil contain many pore spaces? The space between one soil particle and another. Are they many or few, or they are not there? If you borrow knowledge from soil profile, subsoil has very many pore spaces. No, topsoil has very many pore spaces. Subsoil has less, and parent rock is likely not to have any pore space. I think this diagram, when you look at it, you can easily divide it into 3 parts. If you look at this part on right, this side, there are big pore spaces. The soil is porous and permeable. If you pour water, it easily goes through. It passes through easily. And if you look at the middle part, here, this part here, there are few pore spaces, few and small, by the way. And if you look at the left part here, the left part is non-porous, non-permeable, because we don't see pore spaces. It is intact. So I think this determines the soil permeability and soil impermeability. If soil is permeable, it means it has more pore spaces, water can pass through easily. If soil is impermeable, it means the pore spaces are not there, or they are very limited. Water cannot easily pass through. Then we have soil pH as another property. Potential for hydrogen. Soil pH refers to the acidity and alkalinity of soil. Acidity and alkalinity of the soil. How much alkaline, how much acid soil contains. It is measured by a pH scale. The pH scale is numbered from 1. It has numbers from 1 to 14, or 0 to 14, let me say that. And if you carry out your experiment in a laboratory testing for pH, soil pH, and your results are between 0 and 6, you will know that this soil is acidic. And if your results out of your experiment indicate 7, it means that 7 is a neutral point. And if your results are from 8 to 14, it means this soil has more alkaline. The pH scale is here. It is numbered from 0 to 14. Measurements showing 6 and below, that is acidity of the soil. Then measurements showing between 8 and 14, soil has more alkaline. Then if the measurements indicate 7, 7 is neutral point. Soil consistency. This refers to the ease with which individual particles of soil can be crushed. It is the ease with which individual soil particles can be crushed. Some soil particles are hard, others are soft. For example, it is hard to crush, I think, sand than clay if they are still wet. Clay is very soft. Okay, in short, some particles of soil are hard, others are soft. If you are to destroy, you don't destroy all at the same time. Others may resist a bit, others may be soft. soft and they simply crash or get deformed. Then we have soil moisture. This is the amount of water in the soil. Simple. Amount of water in the soil. It is determined by soil texture and soil structure. Then we have soil temperature. This is the degree of coldness or hotness in the soil. Soil, like a human body, also has temperature. Some soils are hot, others are cold. And I think this depends on the climatic regions. This depends on weather. This depends on a number of factors, seasons. And I think soil temperature affects the germination of seeds and plants. It influences soil moisture, etc. This is our last slide. It is about soil air. As we talked about elements of soil, soil has a property called the air, and this air occupies the pore spaces within the soil. So I think the more the pore spaces, the more the air. And the lesser the pore spaces, the lesser the air. Then we have soil nutrients. Soil nutrients. These are chemical elements found in the soil. For example, phosphorus, potassium, and nitrogen, NPK. Then we have soil depth. It is the depth of soil profile from the top to the bedrock, from the top layer to the bottom layer, or to the parent rock, to the bedrock. Some soils or some areas have deeper soils, others have shallow soils. In some regions, soil profile is deep, and some other regions, soil profile is shallow. And I hope soil profiles which are deeper are better than soil profiles which are shallower. Soil density. I don't know, in physics we have density, mass, weight, volume, but soil also has density. It weighs, and it is measured using different units. For example, cubic meters, we have megagrams, like that. Soil may not weigh, different soil particles may not weigh the same kilograms, may not weigh the same weight, I mean. Some soils are heavier than others. For example, I believe clay is heavier than sand. See? Then we have soil salinity. Soil salinity, this is the salt content in the soil. Some soils are salty or saline soils, others are not salty. The process of increasing the salt content in soil is called salinization. It is a process of increasing salt content in the soil. And this one may occur naturally in soil, or it can be caused by natural processes. For example, mineralization, and it can also be caused by gradual withdrawal of an ocean. You know, oceans and seas are marine water bodies, so they can have an effect on salinization of soils near them, or it can be increased through artificial processes like irrigation. Thank you.